Hello, my name is Ashley, and this is Lab 4, which deals with oscillations. So, as an introduction, the purpose of this lab is to examine how the trajectory of an object attached to a spring changes as it oscillates. We can also identify changes in potential and kinetic energies in these cases, and so I'm going to describe the principles now. So, the two main ones that we're using is Newton's second law and the energy principle. Newton's second law used in the past three labs, basically correlating the net force with the mass of an object, its initial position, initial velocities. These are also known as the momentum principle like equations. And then the energy principle basically deals with the total amount of energy a system has and how the potential and kinetic energies change as well as work. So, as a little preview, we're using tracker data and glow script programming to determine similarities in experimental and theoretical data. And so I found that there was little to no deviation in the two sets of data, and that total energy was conserved. So on the left is kind of just a screenshot of what the tracker setup was. The blue line depicts the calibration stick, which I set to 0.7 meters, which was the length of the spring right before the person let go. And the mass was 0.402 kilograms that was given to us. And so I just traced the movement of the object. You can see all those like little red dots. And then I set the origin for the axes at the fixed point of the spring at the top there. And then I put the X and Y position data into an Excel sheet, and then I saved that as a CSV file. And that goes hand in hand with the glow script coding because once I would run the program, you would need data to model the kind of experimental data from the tracker compared to the data that the glow script code puts out. So again, I have the initial mass there, and then I have the initial position vector and velocity vector, which the initial velocity is 0. And then I have some other constants, and then specifically to determine the spring constant, I used the formula at the very bottom, which relates the period of oscillation to the spring constant. And then going back to here, I kind of went from crest to crest and figured out that amount of time, which would be the period, and then plugged in the mass, and then I was able to find K. And then I substituted all the energy equations, and then total energy is just the sum of all of them. And then during the iterations, found the force of gravity, spring force, and then F net would just be those two together. And then using the momentum principle, as I described before, did velocity update and position update. And then that new position would become the new L, and then the cycle continues, finding the new energies at that specific position, and then calculating the difference in the initial energies through each cycle. And then this was the data that I got from that. Okay. And I found that there was little to no difference in the model of the experimental data and then the glow script data, which shows how the total energy of the system stays the same as each component of that energy changes. So the oscillation of an object is mostly accurate, depicted by this code. And so you can see the position versus time graph is generally the same, and then same for the y as well. And then the energy graph, you can see that the orange line, which is delta E, is generally the same at 0. And so some possible fields of error is just incorrect tracking. It's possible that my numbers are slightly off, and obviously that would cause deviation from the model. And then external work. It's kind of hard to have a system that doesn't lose energy. So in this case, for example, it could have been lost as heat, it could have been lost as sound waves, etc. But that could be a cause for error. So now going on to the two what does it mean questions. For the first one, the energy principle is satisfied because, as I mentioned, the orange line stays at 0, so total energy is not changing. And then for the second question, using the period of oscillation formula that's equal to 2 pi times the square root of m over k, I found the k for the x as 5.64, and then the k for the y is 6.98, which shows deviation in that. So obviously, depending on which direction you're choosing to look at, you'll get different k values. So that's something to definitely keep in mind. Thank you.